Okay, thanks to everyone who's here for coming. Apologies for some of the schedule changes. Thanks for being flexible about those. So recall the four kinds of large cardinals with which the mathematical ontology of the immanence of truths is concerned, right? Going up in size, we have the inaccessible cardinals. For today, I think I'll often just write cardinals as K, if that's acceptable. And I'll probably just call them K unless there's a need to distinguish between Ks and kappas, which I don't think there is in this text. But to say kappa just takes too long when you can say K. These are our from below large cardinals, right? Thought in terms of transcendence. And then we have our compact, actually weakly compact, and that's going to be important in a moment, cardinals. And these are the ones that are thought of in terms of resistance to partition, right? And the partition comes from the outside. So in a sense, we're thinking those from the outside. And then we get to measurable cardinals, which Badiou calls complete cardinals. Those are the ones that are thinkable, as it were, from the inside, due to what in this metaphor that keeps growing on me, this metaphor of pressure, talks about the immanent pressure of the large subsets. It also, it makes me think of a lot of early modern science as well, even up to Kant in the Opus Posthumum, trying to figure out how to describe a material universe that's governed by both some kind of principle of expansion, some kind of principle of gravitation. We have some kind of play of forces here that could be nicely interpolated into that discussion. Anyway, we'll get a lot clearer, I hope, about what that means. So these are the ones thinkable from the inside in terms of the pressure of their own large subsets. I think I like pressure because you have to have two things. You have to have an expansion outward, right? Otherwise, there's no pressure. You also have to have a lot of overlap. Otherwise, you would just have a dissemination of pieces floating off into empty space, right? So pressure needs, again, both an attractive and a repulsive force, or if you don't want to speak in terms of an attractive force, at least a lot of overlap. I think we can talk about the attractive force actually in terms of consistency strength. I just thought of this, but it would kind of be fun in that early modern way to talk about large cardinals as having a principle of gravitation that is related to their consistency and a principle of repulsion or expansion or pressure that is related to their multiplicity, to their increasing size. And each of our four cardinals gives us different ways of balancing those two forces. I don't want to the point of a formal analogy, I doubt one could get one that way. So these are key for Badiou, right? They're the key to the entire schema. We blocked out that V schema with the inner models, and the critical point, the least point that's necessarily moved by those inner models is our measurable cardinal. Since we have the big picture about them already, but I was thinking it would probably behoove us today to take a closer look at them and at filters and ultrafilters, so we don't just let that whiz by without any understanding. That is, after all, the assignment of the book, right? I don't know if I read from 290 last time. Sorry, I can't remember. in order to have a clear understanding of the top two approaches, the immanent pressure of large subsets and the increasing proximity to the absolute referent, we need to familiarize ourselves with operative concepts that are as exciting in terms of their strictly formal aspect as in terms of what they suggest about the subtleties of the ontology of the multiple without one. The crucial concept, whose existence I already alluded to in sequel S10, very much in passing if you go back to S10, has, as I said, been given the name of ultrafilter. Throughout this book, I will attempt to give that word the status of a philosophical category rather than dubbing it with another more obviously philosophical term. So the ultrafilter is something that we have to learn to think with and not only to think about, right? It's being promoted from quote unquote mere mathematical content to the level of a category. It's something that we have to use and not only mention. This in keeping with that whole dialectic of use and mention of large cardinals that I've been pushing throughout this. So these are defined in terms of an ultrafilter. We'll get to that in a moment. And then our large cardinals, which start from the measurables. A large cardinal is anything incompatible the real set theoretic universe being the constructible universe. So large cardinals, right, are the conditions for defeating covering over, as Chris reminded us very early on, right, where covering over takes the form of the constructible. And again, we've had that picture of inner models to some extent already, where we have real V and we have some inner model M we're going to be concerned with, and we have the dastardly constructible universe L, and at the very spine, running all the way through it with, as it were, no width at all, we have the ordinals, which every inner model had better have. Otherwise, it's not a model of set theory at all. Okay. Right, so these are from above in a sense. Don't want to over schematize that. All right, so let's see if we can recollect the definition of a measurable kernel. And please just jump in anytime, answer questions, interrupt me, ask questions, especially since we have such a small group this time. I'm mildly curious, how many people feel like they have a good handle on measurable cardinals already? Can I do a show of hands thing with the little hand icon? Medium, kind of, all right. Well, I don't aim for us to go from first principles to mastery in an hour, but I'm hoping that by taking another pass at them, largely following the text, but also introducing some different angles on them, that we'll be able to level up our understanding of them a notch or two. That's all we can do in one sitting. If they are slightly more concrete to us and slightly easier to remember for us by the end, then I'm going to declare victory. All right. So, a measurable cardinal. Or as Badiou calls it, a complete cardinal. I think I went over my reasons for not wanting to say complete myself last time, but I'll just repeat them very quickly. I think I had three. One of them is just that it's a very non-standard term. So if you try to talk to anyone who's been educated in this stuff and you start talking about complete cardinals, they'll have no idea what you're talking about. So you'd have to translate it to measurable anyway. The second is that I worry about talk of completeness anytime we're not being extremely precise about the limits of what is complete there. That's because it's extremely important to me to go back to the fundamental metamathematical duality of consistency and completeness, which is really an intermediate, somewhat developed name for the duality of the one and the multiple, as I think we'll have occasion to recall before the end. And the third one is just that, oh, if you remember, if you remember the measurable, then you're halfway toward remembering what the definition actually is. All right, so without looking it up, can anyone recall what a measurable cardinal is? All right. I want to give the definition, as it were, from the top down, and then let's try and recollect from the bottom up and build up the definition from its pieces. All right. K, a cardinal K, is a measurable cardinal, or is measurable, if, and when mathematicians as opposed to logicians say if, they often mean if and only if, particularly when they're giving a definition. So this is, in fact, a necessary and sufficient criterion. It's not just a necessary one. It's not just a sufficient one. K is measurable if there exists on K. I'm doing this to test myself as well. We'll look at the text. There exists on K something, an ultrafilter, right? A K complete non-principal ultrafilter. K complete non-principal ultrafilter. And when we say it exists on K, we're saying that we can regard K as this enormous multiplicity, right, of elements. And then we're introducing something at the level of the power set of K, namely a way of distinguishing between large and small subsets. Okay. So how would it be if we build up this definition from the filter? I hear no objections. Before we do that, why don't we look at page 290, which is to say number 2 of C14. In number 1 there, he just, I believe, essentially did what I did and reviewed where we are in the 4 forms of infinity, right? And reminded us of the 2 theological analogies that have been deployed so far, divine transcendence for inaccessibles and resistance to partition for compacts. And then we had the invocation at the end, the imperative to get to know the ultrafilter. Okay, so now 2. Does anyone else want to read? Do it. Justin has offered to read in addition to offering to be my interlocutor on the proofs, which is awesome.
All right, should I just start at the top of the section?
Yeah, why not?
All right. When it comes to an existing multiplicity of any kind, You can always say it is either a tautology or begging the question, whichever you prefer, that it is large if it has large subsets. A bit like the way enormous, densely populated cities give the impression of a powerful country, or the way the breadth of real knowledge and the complex singularity of the life experience of an individual seem to destine them for the infinity of the subject they are capable of becoming. If the particular characteristics of a given multiplicity compel it, as it were, from within to be infinite, we can say that the infinity in question can be grasped immanently on the basis of its composition, on the basis, in a word, of its subsets, the very large subsets that only an infinite cardinality can bind together in the form of a single set. Should I keep going?
I think I'm.
Oh, that's weird. No, you're not.
Thank you. Okay. It's large if it has large subsets. We have this just charming invocation of something that doesn't seem very Badusian, right? The complex singularity of the life experience, breadth of real knowledge of an individual. That's very nice. It's not just human animals at the moment. And we have the association of the infinite from within with immanence. So we're getting to the heart of the thing, right? We want the immanence of large cardinals or the immanence of truths. And crossing this threshold, we're going to get it. Okay. Yeah, let's continue. Nobody wants to jump in.
Okay. Note that this immanence, this inner pressure that forces a multiplicity to be infinite based on its internal composition, is not involved in the first two approaches. Indeed, those approaches remain external. The negative transcendence approach starts from operations available outside of infinity and shows that they fail to think a multiplicity that, as a result, will be called infinite by way of a negation, non-finite. The approach of resistance to divisions involves an external agent that attempts in a way to reduce the infinity by inflicting a cut or a segmentation on it that will diminish its cardinality. Once again, it is a negative resource, the ability to resist an external operation, that characterizes this type of infinity. With the immanent infinity, and also, as we will see, with the infinity of proximity to the absolute referent, we are getting to genuinely affirmative characterizations of the types of infinity. The instrumental concept here is not the negation of external resources or constraints, but rather what gives us the means to conceive positively of what an inner pressure, the positive immanence of an infinitizing constraint, might be. The simplest idea seems to be as follows. We will say that a multiplicity is infinite if we are able to explain what is meant by it containing a very large number of very large subsets.
Go ahead.
Ultrafilter is actually just the name of a mental device for measuring what a very large set of large subsets of a given set might be.
Just pause for a moment in case anyone wants to jump in there. And it's the rest of this section that I think is so cool. All right, just to give you a break, I'll jump in there. The difficulty of this task has been well known to philosophers since antiquity. The notions of large and small are completely relative and do not seem to be able to give rise to a stable concept. Perception is misleading where this is concerned, because what is large in relation to one thing may be small in relation to another, which means that perception is incapable of clearly distinguishing between the large and the small. Socrates sums this up wonderfully in the Republic. I'm giving my own version of the passage here. We said that sight perceived large and small, not as separate, but as conjoined. To clear this all up a bit, pure thought is compelled to conceive of large and small as distinct, not as unseparated, and therefore to contradict sight. Here we have a patent contradiction between seeing and thinking. It's this contradiction that prompts us to try to find out what large and small really are in their being. The whole problem is thus to determine how we can conceive what is large in itself. Or more precisely, in this particular case, what a large subset of a given multiplicity is, and still more precisely, what a set, itself large, of large subsets might be. I'm going to track all the different places in which large occurs in this characterization. It is the inner pressure of the countless large multiplicities contained in the set in question that will determine from within, in immanence, its infinite size. All right, so the fundamental difficulty is that large and small are, quote unquote, completely relative. You can see that most clearly in Plato in what I think are always reductio attempts to treat large and small as predicates. So if you want to say Socrates is large when standing next to Charmides, that's one thing, but then when he stands next to Alcibiades, you want to say that he is small, right? And the all too quick logical lesson that can be used to dismiss Plato on this point and therefore prevent the dialectic from starting at all, because these are the summoners to dialectic, these contradictions in the large and small treated as predicates in perception. In the Republic, that is what kicks off the dialectic. The all too quick thing we could say about it is, oh, this is a pseudo problem. Plato doesn't understand that these things are relations and not monadic predicates. This is almost certainly what Russell thought, but then Russell thought that about everyone up to Frege, including Hegel. Frege, on the other hand, who at least read Plato in some adequate way, credits Plato with precisely this observation, realizing that there are relations which are subtended by multiplicity or numbers, and that these are not predicates. It's at the end, I believe, of the Hippias Major. It could be the Hippias Minor, I forget, but I think it's at the end of the Hippias Major where Frege explicitly quotes Plato on this, because Hippias is wound up in this sort of Meno's slave type position where he's reasoning reasonably, but overly led by language, right? And he wants to say, well, if Hippias and Socrates both share a property, then Hippias has it and Socrates has it. This arose in the context of trying to define the beautiful. And Socrates says, well, what about the property of being two? We have it together, but it does not follow from the fact that Hippias and Socrates have it, that Hippias has it and Socrates has it. You might say a little facetiously, but only a little, that in that sense, two is the first inaccessible cardinal. You can't get there from a logic of monadic predication. It's even less facetious, as you'll remember if you read the Rucker, that two is, I believe, literally the first measurable cardinal, although we don't put it that way. but it's what gives you a strict 1-0 measure on its subsets.
Sorry, John, could you say that just one more time? I missed that.
I hope I'm not
What
wrong.
what were you saying about 2? I meant
yeah.
something.
So first I said in a slightly humorous sense, you could say that 2 is the first inaccessible cardinal because
Yeah.
you can't get there from below with predicate logic. Meaning Aristotle's subject predicate logic, monadic logic. And then I said, if I remember properly, there's actually a literal sense in which 2 is the first measurable cardinal, although of course
Measurable. Okay. Yeah. All right.
We don't define it that way because we define for convenience a measurable cardinal to be uncountable, and that rules out omega as well, even though just like with the inaccessibles, and this helps to remember the motivation, omega is in fact a measurable cardinal by the definition. There does exist an omega complete non-principal ultrafilter on omega, and the crux is you cannot construct it. It's radically unconstructable. That may come back into play later when we talk about Zero-Sharp and Silver's theorem. Okay, but back to the text. So our first move, the difficulty is large and small are completely relative, right? The first move is to say a multiplicity is large if it has large subsets. And that is a first step. But the natural thing to do then is to ask what a large subset is, right? And if we do that, we beg the question. Because if we knew what a large subset was, then we could simply use that knowledge to say what a large set is. I think this is subtler than it sounds and rather cool. So how are we to move past this impasse? If we try to say what a large subset is, we're presupposing the thing we're looking for. So we will try to define the large not in terms of a large subset, but in terms of many. And I think the way Badiou presents the necessity of that transition here is just beautiful. I'll pick up at 291. So first we have a sort of intuitive motivation for this step. Experience clearly shows that it is the localized system of power zones, their possible overlapping, that characterizes a real infinity, and not the intrinsic definition of an isolated quantity. Creativity, whether collective or individual, is always realized as a complex of works, a system of local distinctions, a burgeoning surge of variations, in short, as emerging multiplicities. The quantity, the mere quantity of a political, existential, or artistic production of truth ultimately lies in the relationship between its constituent parts rather than in an isolated totality. So the quantity that counts is not mere quantity, the kind that seemingly could be predicated, right? Indeed, I have suggested that the true subject, the one that unfolds the consequences of an event, should be called a configuration rather than a totality, and that configuration is the name of an activity here. We could say that an action of truth configures a complex of large subsets in the situation that reveal, in immanence to this situation, the power of a new infinity. And I take it that large is in scare quotes here only to indicate that in a way we don't have the right to use that adjective yet, for the reason that we just mentioned, right? It would be self-presupposing. But we will learn what we want to mean by a large subset by means of this overlap. And here's the conclusion, and I've never seen anyone else, it might be standard for all I know, but I've never seen anyone else try to explain why we're suddenly talking about a multiplicity of subsets here with measurable cardinal. But he presents it as a natural dialectical transition. There's no other way out of this begging the question. That is why, on the ontological level of the question, the rational approach is not and cannot be for us to say exactly what a large subset of a set is. that would mean getting unavoidably involved in the indivisible dialectic of the large and small that Plato requires us to stay away from. Bookmark there. We will instead suggest the concept of a network of subsets whose links with each other, as well as what they exclude or constrain, show that most of them are at any rate so large that they can be said to be almost equivalent to the initial situation, to the set of which they are subsets. And then we have our political example and our artistic example. Of course, the political example is the overlapping groups, right? Each of which is equal to the situation in I think, both the literal and the idiomatic senses of that, right? Equal in, they're up to it. They're equal in power to the needed act, the one that bears decisively on the situation. The artistic example was new to me. We need to think of how many different capacities in the creative process are combined in a painter's single gesture to understand that the measure of a new infinity lies in the local conversions of disparate multiplicities. So I take it that the gesture itself is the overlap there, and that it belongs to a large number of large categories of the artistic object. The artistic gesture seems to be constitutively overdetermined, if that's right? And constitutively overdetermined in a way that can't be explained reductively, that can only be explained in terms of the immanent relations of the categories or large subsets that are proper to the work. And that really does seem nice. I think, of course, of Virginia Woolf's Lily Briscoe and the great irreducible complexity that is found in the single gesture, in drawing a line here, or in painting a line here. Why should that be so complicated? I think a beautiful account of why here. Okay. Let's try to zoom without reading literally through the next several sections. So let's go back to the somewhat dry work.
So just as a quick little forecast, if you're interested, later in the book, he'll talk about what's called the materiality of the work of art, which would again be something like, the canvas, the paints, the oils, all the, sets of elements involved in the artwork itself can't be reducible to the art itself, the truth procedure as such.
It strikes me that even the phenomenologists, Merleau-Ponty, for instance, right, are trying to describe that phenomenon. He does it through the category of synesthesia, right? I mean, he thinks this is true of embodied reality to begin with, but as it's played out in art, the red of the apple and the red of the fire engine aren't the same thing, right? So there isn't this analytic distinction between form and color or what have you. And there too, I think we get, in the rather vague concept of synesthesia, an attempt to talk about this overlapping. If this works, it'll be much more precise. Is that fair to say, Chris? I think you're muted.
Yeah, like I said, it's just a matter of you can't reduce it down to like theater, for example. An opera can't be reduced to, every component of the theater itself, or, the costumes or anything. It's a combination of all the things and how they interact and work together.
We should talk about this more, and I'm hoping to talk about it next time. At each level here, as we get larger and larger large cardinals, we get stronger irreducibility properties. Because we have ways of being one or being consistent that you can't articulate on the basis of weaker notions of being one, just as you have vast multiplicities that you can't describe, say, by means of using the axiom of replacement on power set and union in terms of these smaller multiplicities. The first example that we saw of that quite a few weeks ago, I think, was the strengthening from consistency to omega consistency.
John, can I say something as well here? I think it's important, like I've been thinking about a lot, which is with respect to the Baidu part of this as opposed to math. But on the math side, I think what we have to remember, what we're doing in these endeavors is we're asking the question to some extent, if you take ZFC, what are other hypotheses that we can add on top of that, right? Gödel suggests one, which is that V equals L, right? That's a hypothesis, right? And that gets you to a certain level on this hierarchy. We've shown.
Of course, he doesn't really suggest it. He just shows how we can write it down.
Sorry, you can write it down, but then it can be assumed. I'll try and find the part where he talks about it as an assumption and what it means if you assume it. I'll try and go back and find it. The point being, beyond that, we're looking at other assumptions. So when we're talking about large cardinals, we have to make assumptions to add to ZFC. So when you're saying there is, I don't know, a measurable cardinal or a Wooden cardinal or whatever one we were talking about that's higher up, which is a large cardinal, we're saying there is this cardinal and these are the properties, and this is what defines it as X. You know, and we're adding that into our axioms, right? That's what we're doing in these cases. So we're assuming things, right? And so large is, there's lots of different things which make something a large cardinal. And then part of the endeavor is discovering those or figuring them out. And then the second part of the endeavor is putting them in a hierarchy so that some are contained within others and others aren't.
Right. And of course, that's been one of the strongest arguments for realism with respect to the large cardinal hierarchy, right? We have all these diverse notions of why, of what might, with some plausibility, be expected to exist as the large cardinal. But we didn't design them in such a way that they were all supposed to line up into a linear hierarchy. The fact that they do is extraordinary and makes lots of people feel that, well, that's something that reality told us. That's not something that we simply postulated.
I agree, but I guess the point is that what we're doing is we're assuming, we're making assumptions, right? And that's an important thing to remember as we go about this endeavor.
Certainly, although it makes the question of motivation for each assumption all the more crucial. And I take it that what Reggie was just doing with the fact that we can't define the large in terms of one large subset, that's not a completely formal argument by any means, but it's one of the more remarkable examples of motivation that I think I've run across. And it, of course,
no, I think that's completely true. Yes.
And of course, as you know, much more directly, the motivation for measurable cardinals comes from topology, comes from the idea of trying to extend the idea of dense and sparse subsets, say, of the real line to a large cardinal. I hope I'm actually going to get to that and why that is a way of forcing a cardinal to be extremely large. Why don't we finish recalling the definition, and then I can cut it down to 3 points and 3 observations about the definition of the ultrafilter here, and then we can ask for more interpretations. Will that work? All right. I'm going to try and do this by memory, but I've called it up as well to prevent me from making horrible mistakes. So we want to go all the way back. We said that a measurable cardinal has a K complete non-principal ultrafilter. on it. All right, so the smallest conceptual unit there is filter. So let's go back quickly to the filter axioms. The motivation for a filter is this idea of having a measure that will, to some extent, bring axiomatic order to this treacherous but essential dyad in Plato, the large and small. Forgive me, just one tangent, by the way, it's not at all a matter in Plato of simply having to avoid the intractable relationality of the large and small. As I read it, in the Republic, it looks like that in order to kick off the divided line. It looks like we're getting farther and farther from that. But like the Tübingen people, and like Kenneth who made the case in a way that's utterly convincing to me, I'm strongly convinced that what Aristotle reports and Aristotle students report about Plato's last position in ontology, Plato's final ontology, is sound. This is sometimes referred to as the unwritten doctrines, but I think if you know how to read the dialogues, they're pervasively written in a way he writes nothing else. Even in the Socratic dialogues, you can see the dyad coming out. Anyway, that's this idea that the ultimate principles or archai are the one, tohen, and the indefinite or infinite dyad of the to aristos duos, like the aorist case, which is indefinite with regard to what reference point we're using. Aoristos or ahoristos for some reason if you're German. So the one and the indefinite dyad, and which always is the compound of this inseparable relativity. One of the most classic names for it is the great and small, taken as inseparable. Hyphenating it is a good idea. And once you start looking for that, it's all over Plato, and not only a point of departure for eidetic analysis. The very brief story is that you get forms and concrete things from two doses of combination of the one and the dyad. So you have the one and the dyad interacting first, and you get the forms, and then you have a second dose of the dyad applied to the forms, and you get ordinary material things. The fact that you have this double dose of the dyad, which is to say you have some kind of proportion operating first linearly and then in square, should certainly make one think about going down the divided line in retrospect. Anyway, there are a lot of other things to say about the great and the small in Plato, and I will try to restrain myself. To some extent, I'm pushing back, not just against the throwaway remark here about leaving the dyad behind, but also the decision to position us over and over again with regard to the megastegene, the highest kinds in the sophist, when there is this other framework available in Plato that may have much more direct things to say about the one and the multiple and the infinite, and the construction of temporary, of reasonably consistent and complete mathematical objects, which are going to be compared to modes, right? Okay, so anyway, motivation for the idea, even of a filter, is to try to define some kind of measure, and this is always an act in Plato, right? The measure isn't there simply naturally to begin with, as Aristotle flattened it into the doctrine of the mean, right? Oh, you only have to find the mean between black and excess. Now, for Plato, even in the Statesman, for example, the work of the true statesman is trying to introduce a proportion that harmonizes that harmonizes the great and small, right? This is never something given by nature. It's a work of art. It's an ethic, I think, in Plato, and that hooks up nicely to Bettier's ethics of truths here. Right, so how can a measure come to be? We start with 4 intuitive axioms for a filter. Axiom 1. Well, if we have a set and we're dividing the large and small, then the whole thing should count as large, right? So we're given a set S. S is large. Our filter is going to be the collection of large sets, large subsets. So to say that S is large is to say S is in the filter. The sets that we're counting as large are in the filter, the sets that we're counting as small are outside of the filter, right? And I think Beggio even gives the metaphor somewhere. It's as if we had a sieve or something, and the subsets that are large enough are caught in the filter, and the small ones just pass through irrelevantly. So S is in the filter. That's pretty trivial. Axiom 2, what's the one thing that we can all agree to define as small? Well, the empty set. The empty set is small if anything is. When we get to principality and non-principality of ultrafilters, though, remembering this is going to be one of those extremely strong motivations for generalizing from filters to ultrafilters and to non-principal ultrafilters, because it turns out, and you may recall this from the reading, that in order to get a non-principal ultrafilter, if you've built up an ultrafilter in the right way, in a way, the step is trivial. In a way, all you have to do is assert that not only is 0 small, but 1, or the size of a singleton, is also small. And that just seems sort of incontestable. But the leap in logic and cardinality just to take that one step from 0 to 1, it marshals all of these conceptual resources associated with the measurable cardinal. So that's one of those motivations by analogy with something quite familiar. And it seems incontestable to say that singletons ought to be small. Right. So axiom 3 is the important one, in my opinion. This is the intersection axiom. If A and B are large, so if we call our filter F, we're saying that A is an element of F and B is an element of F. Then A intersect B is still large. Now, that is not necessarily obvious, I think. This is a really strong commitment to saying what we mean by large sets having large overlap. One way that you could think about it is if you take, say, something like the real line, and you take some open intervals on the real line. Well, if they overlap at all, if they intersect at all, they're going to intersect in something that has the same cardinality as R itself, right? Even if it's a little open interval, that has uncountably many points. It has Beth1 points, and therefore you could map it onto all of R. But that's not the only thing at issue. We'll come back to that in a moment. Cardinality is not king here. Anyway, that's axiom 3. When we get to get to an ultra filter, you just strengthen this axiom. What this is talking about is the intersection of 2 sets, right? So you can't go from the large to the small just by intersecting 2 sets. Well, how many could you try? 3, a countably infinite number, or all the way up to k, the size of our original set, which is what we're actually going to get, anything short of k. And finally, axiom 4 is pretty trivial. If you have, here's our set S, right? And if you have a large subset, A, that is in the filter, then if you have something B that includes it, it had better not get small all of a sudden. What includes the large should be large. So if A is in the filter and A is a subset of B, then B is in the filter. The fact that these also look like basic logical operations is no accident. I know this is a hell of a thing to say to just toss out, but remember that topology and logic are essentially the same thing. And it's as if here we had the truth value object, or 1, or the true. Here we have the false, or 0. And here we have a rule for conjunction, right? Because the intersection between A and B, we know this just from like grade school, working with Venn Euler diagrams, right? If you have A and B, then their intersection is A and B. And here you have a rule for implication. So the topological motivation for this also, almost by accident, builds up a logic. And indeed, ultrafilters are of primary importance in both topology and model theory. Okay, so that gets us a filter. What do we have to add next?
To get an ultrafilter?
Yes.
Can I just ask something quickly?
Please.
So how far does that analogy go? Like in that case, would there be, is there a parallel for negation? Is there an analog for negation in that analogy?
Oh, sure. Sure, the complement.
Oh, okay.
The complement of a subset in a larger set. And in fact, the fact that that works so nicely is going to be the mechanism for proving those little theorems at the end of this chapter, the one that he calls the egalitarian theorem, and the theorem of resistance to partition, which we should probably skip, and the proof that measurable cardinals are large to begin with, which you get by proving that they're inaccessible. They all just play on negation and the complement being intertranslatable into
right. But I guess what I was driving at was, so what do you need to set up a basic positional logic? You need, well, you need some version of implication, some version of negation, and then either conjunction or disjunction. So I mean,
you can do it, if it's classical, you can do it just with negation and any binary operator. conjunction or disjunction. I
Oh,
shouldn't
yeah,
say any,
no,
I
yeah,
shouldn't
that's
say
true.
any one, because I don't think you can do it with just negation and implication. No, you can, because you classically you can just turn that into disjunction. If P, then Q means not P or Q, right? So yeah,
Right.
you can do that immediately, and the power of this ultrafilter stuff is that you can eventually get analogs to things like quantifiers and higher order quantifiers and infinitary quantifiers, which I will try to mention maybe next time when talking about infinitary languages as another angle that we can take on this large cardinal stuff.
Thanks.
Okay. Ultrafilter. So we have to satisfy axioms 1 through 4 to be a filter at all, right? And to that we need to add a new axiom, ultrafilter axiom. And what is that one? Speaking of negation, it's a kind of completeness axiom, right?
This is the complement one, is that correct? Yeah.
Yes.
Okay, so either a set or its complement are in the filter.
Exactly. So if we have our set S and we have some subset of S A, and here's our complement, which for some reason he writes that like a predicate, right? With a C or something, or sometimes even a CP or something like that. But we just mean not A, the complement of A in S. So allow me to do that. Then either A must be in the filter or not A must be in the filter. And it's easy to see not both. So again, we have a very immediate analog to a logic here, right? One or the other has to be in it and not both. One or the other has to be counted as 1 and not both, and the other has to be counted as 0. This is an assertion of both excluded middle and non-contradiction. So we're getting closer and closer to something like a full logical language by passing to the ultrafilter. Can call it a completeness axiom. If A is a subset of S, then you prove this, but let's just say exactly 1 of A and the complement of A in S are in an ultrafilter on S. So another way of looking at that is to say we can take the entire power set of S and divide it, strictly speaking, down the middle, right? This is S is made up of all of these pairs, and in each case, one of them is counted as large and the other is counted as small. So we have a division right down the middle between the large and the small. Just being an ordinary filter doesn't guarantee you that. Okay. Principality. You can define principality and non-principality on a filter, which is worth doing, but for time's sake, let's just go ahead and define them on the ultrafilter. characteristic of a principal ultrafilter.
May I?
Please.
In a principal ultrafilter, all of the subsets that are in the filter have some subset in common. And it turns out that has to be a singleton.
Yes. So let's skip over treating that as a theorem, and for the moment, we can just build it in as an axiom. So if we represent the power set of S this way, right? Our smallest subset is the empty set, our largest subset is S. Then a principal ultrafilter is one that's going to start right here at level 1. It's going to pick out some singleton, in other words, something, a subset corresponding to exactly one element of our original set. And the filter, the ultrafilter is going to consist of, it's an equivalence, it's definition. It's not just going to contain, it's going to consist of simply all of the subsets that contain that element. And Bediou has many and critical things to say about this element, right? It's just the kernel, pun intended, of ideology. Okay. So, principal ultrafilter, let's say this loosely, all the filter elements intersect in some singleton X where X is an element of S. There was a famous paper, as I recall, I'll probably get in trouble because I'll say this wrong. This famous paper, as I recall, by the analytic Anglophone philosopher of mathematics, Paul Ben-Asaraf, called "What Numbers Could Not Be." And one of the arguments there is that this set theoretic, this attempt to describe numbers as sets is really weird because if we accept it, then we have to be able to explain the difference between X on its own and singleton X. In contexts like this, that seems extremely natural. We're talking about the difference between a point as a point and a point as a region of zero extent. And that's quite different, right? You can be a club or a corporation of one, but that's not the same thing as being an individual. All right, so non-principal ultrafilter has to, if I can put it this way, combine two properties. And in this way, it's very much like an inaccessible cardinal. It combines two properties that are difficult to get to mix and that ZFC can't necessarily get to mix. Yeah, just quickly, in the case of the inaccessible, you'll recall it's regularity and being strong limit, which is to say not being able to get there by means of union and not being able to get there by means of power set. Chris.
Hi, so one thing to keep in mind, I'm looking at diagram 3 at the end of the book, and then I'm also looking at page 310. In the diagram 3, you get the implication here that, yes, I'll just read it. It says, suppose that B is the one of a principal filter. It is clear that neither A nor the complement of A belongs to this filter, neither contains B completely, right? There's some of B in the complementary of A, and there's some of B in A itself. And then basically the implication here is that this is a principal filter. This principal filter itself cannot be an ultrafilter. Right. Now, what this also ties to on page 310 is Badiou reasserting his Maoism here, is given any set, this is middle of the page, given any subset whatsoever of S, it is ultrafiltered in the following sense. Either it is in the ultrafilter or its complement is in it. We said that analogously, an ultrafiltering is a filtering appropriate to a situation produced by an antagonistic contradiction. And so the idea in Maoism is that you have contradictions among the people, Are they antagonistic or are they non-antagonistic? Between the peasants and the landlords, it's an antagonistic contradiction. But during say an invasion by a foreign occupying army, you can form an alliance between the peasants and the landlords to fight the Japanese. That's a way of non-antagonistically handling the contradiction, as opposed to say antagonistically handling it through land redistribution. But the question is what does the situation at hand call for? So that's what's clicking for me between what is a principal filter and what is a non-principal filter.
That's great.
Is it antagonistic inherently in a contradiction, or is it strictly speaking a non-antagonistic contradiction?
And in diagram 3, that's page 593 for everyone. It took me a while to realize why it's there. Oh, by the way, there's this pervasive printing problem in the book where you have these E's, capital letter E's that show up where they're not supposed to be. So this label for the large circle out here ought to be S, S for set. And of course, you can immediately realize what happened, right? There was an E there for ensemble, or set in French, and they forgot to change it. Often in the text, it's even a little crazier because the E shows up there alongside the S. Anyway, this is a small thing, and as long as you realize that E is always S, you won't be confused. But one thing that's nice about this as well is that it is essentially a visual one-shot proof of the fact that that being a principal ultrafilter means being founded on a singleton. Because you look at this diagram, we're given, right, that B is the stationary set, the hard kernel, the one of a principal filter that all of those have in common, right? A is half in and half out with respect to B. Well, what's the only way that we can be sure that can't happen? That it can never happen? Well, we have to contract B to a single point, singleton. So that then there can be no overlapping that isn't a straight up, yes, it includes it, or no, it doesn't include it. Of course, we have the topological basis there for something like a fuzzy logic if we then want to withdraw that distinction. But let's get the classical version first. Okay. Then non-principal filters are the good ones, right? And then it only takes one more step to get to a measurable cardinal. And that's K completeness for our non-principal ultrafilter. And that's a generalization of axiom 3, as I think.
John.
Yeah.
Sorry. I've just somehow, I just completely lost the thread of what a non-principal filter is in that discussion. Would you be able to go back and just recap before you move on?
Yes, of course. The principal filter is
I got the principal filter, so it's non-principal filter just the negation of that principle?
Yes,
okay,
it is.
All right.
And at first, that's difficult to picture. And the task of coming up with a more positive set of mental and real schemata for that non-principality, that's a real task. Like when you're, that's largely equivalent to the task of coming to some kind of eidetic intuition of what a measurable cardinal is and why it has to be big.
Okay, I just wasn't sure whether, yeah, all right, I got it now.
So, just want to make sure I've got it right. Yeah, so this is very easy. In axiom 3, we had that if A is in the filter and B is in the filter, then A intersect B is still in the filter. It's still large. And that's to say roughly, if I have A I'm starting with in the filter, and I try to use B to cut down on the size there, it won't work. The overlap is still large. And so the natural question is, well, what if I really want to cut down that overlap and start introducing third and a fourth and a fifth set to try to get that intersection smaller and smaller and smaller? Well, K completeness is the ultimate way of resisting this. And if you're wondering, by the way, where lambda completeness went, it showed up as an exegetical device and then dropped out. It's because, in fact, there's nowhere else to live between omega completeness for an infinite form of completeness and K itself. You actually, it's actually easy to prove that you can't have some lambda in between omega completeness and K completeness. So it's another way to get the feeling for why immeasurable cardinal is so huge. The criteria propagate all the way up to the level of K. Right, so all we have to do now is get to axiom 3 star. Let's call it. Mathematics is all about flipping foreground and background, right? We take this to be a statement about A and B, but it's also a statement about the number 2. It's saying that in this context, the number 2 has this property. If you fill in number 1 and fill in number 2, then this happens. Well, use that as the pivot and take 2 all the way up to K. And then you have the intersection of less than K sets in the filter is still in the filter. In other words, no matter how many times you try to add sets to cut down that intersection, if you're adding less than K of them, it doesn't work, still large. Incidentally, quick puzzle. Why shouldn't we define K completeness to mean that the intersection of K filter sets is still in the filter? Why is it less than K? Because you can always, if you allow K intersections, you can always reduce the intersection to 0, right? Because our set has K elements. And consider the set, I'm just going to pretend that they're natural numbers right now. No, we can use general ordinals. I'll just start at the natural number end. Okay, so the first element in our set is x1. Second element in our set is x2. Third is x3. Thank goodness for the axiom of choice. We can do that no matter how many infinite ordinals we have to plow through, right? Okay, well, consider the subset of K that consists in the whole set minus x1, only leaving out x1. Well, that had better be large. Same thing for x2. Take all of them, however, there are K of them, and every one of them excludes one element of K. So the intersection of all of these is empty. And that's the one inviolable principle. So that's not even a filter. So we don't have to bother ever worrying about this equaling K. Okay. I want to give 3 very quick observations and then turn it over. And there will be more to say about each of these. I'm trying to write up a thing about them right now. So 3 observations about how this is weird and interesting philosophically. First, recall Galileo. In our standard history of the infinite, right? Galileo is a good job, you almost got there figure, because he sets up the one-to-one correspondence between a set and a proper subset of itself, right? So just give the classic example, doesn't matter whether it's his, 1 is paired with 1, 2 is 1 is paired with 2, 2 is paired with 4, 3 is paired with 6, 4 is paired with 8, right? And so you get that there are exactly as many evens as there are natural numbers, even though the evens are, in an intuitive sense, exactly half of the natural numbers, right? And we say, and rightly so, all it took to allow the Cantorian theory of the infinite to take off as a legitimate mathematical subject is to change this seeming paradox into a definition, right? So we get Dedekind's definition of the infinite. An infinite set just is a set in which the there exists a one-to-one correspondence between some proper subset and the set itself. All right, brilliant. One of these like relativity-like moves where we just realize we need to eliminate something. There was a problem we thought was there. Take it away. There's no ether causing trouble. Okay. But Galileo was on to something. He was not on to cardinality. Because these 2 sets are cardinally identical, because there exists a one-to-one correspondence between them. But if we're doing like a first course in set theory or a 3rd course in logic or something like that, we're inclined to just leave that as a surpassed moment in our dialectic, right? So Galileo says, there's still this difference. And we say, well, we've shown that the difference doesn't make a difference, cardinally speaking. Well, when we start looking at the ultrafilter, the Galilean difference has returned at a much higher level. So yeah, we were allowed to go to sleep and forget about Galileo's problem all the way through ZFC, at least if we don't want to worry about filters and ultrafilters in ZFC, which we should do because they're useful for topology and whatnot. But as far as the large cardinal story goes, when that intuition, which we thought was left behind at the very beginning, returns, it returns an extremely high level, the level of a measurable cardinal. So if we take our power set again, the Galilean intuition that some infinite sets are more infinite than others is back. For instance, S is large, right? All of the cofinite sets in S are large. And we just gave an example of cofinite sets, namely take all of S and throw out some finite subset and take everything that's left, nearly everything, as Beju makes a point of saying, almost all, right? So here we have the cofinite subsets, which make up a filter, not an ultrafilter. They make up a filter called the Fréchet filter, and all ultrafilters have to include it. And we agree that the finite sets are small. So we've divided the large from the small in that sense, making use of the Galilean idea. And then there's a ton in the middle that has to be divided, as it were, down the center. Because as you recall, in our ultrafilter is complete, right? So this is one pair of halves, and this is another pair of halves. So I would suggest, this is something that I'm still puzzling through, but I would suggest that in fact, we have two kinds of Platonic division combined in the ultrafilter in a way that Plato could not have foreseen. We have the division of the small from the large, but we also have that division down the middle that the Eleatic stranger is so fond of talking about in the Sophist and Statesman, where you'll recall a division that produces something like a finite and a cofinite set is the very paradigm of a not good division as far as the stranger is concerned. Divide the evens from the odds into two equal halves, excellent. Divide Socrates and everyone else, or even humans and all the remaining animals on the other side, bad division to divide down the middle. So Beju mentions this first aspect of division, separating the large from the small. But the other one is there too, because all of this is in the ultrafilter. And there has to be some kind of arbitrary decision here that picks out certain properties as being analogous to the large and other properties as being analogous to the small. But it's essentially by fiat. So it's that for one thing helps you understand, in addition to being a very weird cut, right? There's a cut that divides the large and the small at the extremes and divides the middle down the middle. That's really fun. But in addition to that, the fact that there are so many ultrafilters, in fact, there are 2 to the 2 to the k non-principal ultrafilters on any infinite set of size k. So that's doubly exponential. This gets you the power set. This exponentiates the power set. That division, that extraordinarily large number corresponds to the different ways in which you can somewhat arbitrarily divide up the middle. And that leaves lots of room, I think, for infinite expressions of the infinite in the way that Beju wants there to be. Because all of the ultrafilters, all the non-principal ultrafilters agree about the top here and the bottom. So that doesn't distinguish any of them. It's the variation in the middle that allows things to be ultrafiltered in many different ways. I can mostly pick up here next time. I'm sorry I went so late. I'll just add one terminological thing where it's probably not this way in French. So Beju missed a lovely chance. But in English, a non-principal ultrafilter is also called a free ultrafilter. That's rather nice. Beju would associate the principal ultrafilters with domination, right? And the non-principal ones with liberation. Well, in one of those terminological accidents that he likes so much, indeed, non-principal ultrafilters are free. All right, much more to say about that next time and what have you. But I want to turn things over to Jim with apologies for having run on so long.
Did you want to go ahead and play the recording first, or?
What do you think?
I mean, I think that would probably be I think that would be the best thing to do. I don't know. Either way would work well. In fact, it might be best to play at the beginning and at the end. But I don't know if we have time for that, or if people have patience for that necessarily. So,
I strongly agree with you that we should play it. So, Daniel, if you can help us for copyright reasons, or you could cut it out afterwards, I suppose. You might want to turn off the recording, and then can we get the audio from Jim's YouTube to come through?
Oh,
Well coordinated and everyone stopping around the same time.
mine is over. I'm gonna go ahead and screen share again. I chose that video just because the pianist is Messiaen's second wife that Badiou mentions in the text. I figured that would be a reasonable one to go with. Actually, you know what? I'm going to stop share for a second. So I mainly have a lot of questions to raise about this, and so I thought I'd begin just by reading through the basic argument that Badiou is making. So this is on page 481. He says, "Everyone, I think, has at one time or another around the month of May heard the amazing, powerful vocalizations that the male blackbird produces to attract females. And just quick side notes, I have not had that pleasure myself, being a North American, and so the blackbird is a Eurasian and also in North Africa, I think, species, but it's in the same genus as the American robin. So if you're a North American like me, and if you're a birder, or even anybody who's paid attention to bird song at all, probably heard robins singing, and robins sound somewhat like the blackbird, though it's a pale imitation, I'd say. Not as much variation in the robins. But anyway, so continuing on. The blackbird is without a doubt the greatest virtuoso in these parts. Messiaen wrote a flute examination piece, hence a virtuoso piece. His aim was to project the natural virtuosity of the blackbird into the sonic abstraction of a musical score. Messiaen basically wanted his score and its performance to be like a prayer, glorifying in humanity's capacity for ingenuity and therefore for work, the natural virtuosity that God makes sing in the realm of his creation. This, at least, is what he explicitly claimed. But a work once absolutized cannot simply be a response in the form of a prayer, a song of grace and honor of the divine work. I would like to show how, in truth, literally, Messiaen's score is always involved in a rivalry, a bitter rivalry with the birdsong, which admittedly it also humbly captures and reproduces as far as possible faithfully. Messiaen's subtle undertaking consisted in inscribing in the musical texture of many of his works an anticipation of the finitude that might enclose it in the form of an explicit inner reference to a purely self-sufficient, because natural and or religious exteriority. So I think that gets across the general idea there. And I think that in the broad strokes that I don't find much to disagree with. If you're familiar with Messiaen, you know that these were two extraordinarily important parts of his life, and that find their way into his work. I mean, bird song or just the natural world in general, and then his religious faith, which was enormous. In reading this analysis, and I do find it remarkable, just as another side note, that there's such an extended analysis of a piece of music in a major philosophical work, which is not something you see particularly often. I'm not sure when the last thing this extensive has appeared in, at least in anything that I've looked at since, maybe Adorno, I don't know. But in any case, what I thought was the main questions I want to raise have to do with the relationship of this this work, which I'm assuming that he's considering the piece, the Blackbird, as a work, and but he doesn't specify exactly to what event it's partaking. He does say that in the definition of a work, this is right at the beginning of C22, so like page 448, that a work is a finite linked set of consequences of an event, and so on. It has evental origins, and so on and so forth. And so first question I asked myself is, well, what event is this with the origin of this particular work? The only real, as far as I can recall, the only real musical event that Badiou has talked about to any extent is the what he calls the Schoenberg event in Logics of Worlds, and there, if you recall, if you've read that part, I've read it many times just because of my focus, but he is basically going through and giving a typology of different affects that those who are faithful to some event represent. So, for example, like Berg is an example of anxiety because he's not able to let go to the same extent of tradition. Webern is courage, I believe, and he says Boulez is the terrorist, essentially, of the 12-tone world, which pretty much tracks for the most part. And he also mentioned Dutilleux, who is another French composer, and Dutilleux only interacted with the 12-tone method a small amount. I've done a lot of work on that music. And I'd say that Messiaen at least engages with that tradition to the extent that Dutilleux does, if not even more. So and part of the reason why I don't understand why he doesn't bring this up is because the piece itself, the Blackbird, is the final part. If you remember that there's a kind of going back and forth between what are evocations of the bird song and what I think Badiou accurately describes as a sort of place setting, like he described, and partly because this is music that's familiar from Messiaen's Tarangalila Symphony, where he also incorporates bird song, but it's specifically depicting a garden scene. I think that Badiou is probably calling on that kind of imagery. But in the last section, this piece is actually Messiaen's most straightforward use of the Schoenbergian 12-tone method in his entire set of works. And so am I sharing? I don't think I'm sharing. Am I sharing my screen? No, let me share my screen. I'm sorry, Chris, do you have something to add?
Hi, so just a quick context for the section we're discussing in chapter 23. It's at this point, it's Badiou who has completed the sort of mathematical proofs of yada yada yada, and then you go to the concept of indexing for works of art.
Right.
So at the top of 474, he's actually given this critique of Kant. So he says, yet at this point, Kant cannot distinguish between natural and artistic beauty. He's talking about the idea of pleasing and the universal pertains to the thought. The real landscapes, the painted landscape, the Blackbird in the month of May, and Messiaen's Blackbird, they are all the same thing. This amounts to neutralizing the obvious difference between the two, the difference that makes the truth, that is to say, human creation, of the works of art so valuable. So for Kant, what's the difference between hearing the birds and hearing the music? They're both pleasing. So is it art? I don't know.
Sure.
You go further down on 474, the big italicized section. The index of a work of art points to the absolute through the element of formlessness the work contains, compared with what the previous state of visual or auditory perception regarded as constituting a form. just as the touching of the absolute occurs ontologically through the cardinals, whose absolutization of a work of art occurs through forms that we assume at the peril of the work to be the artistic forms, even though it would be impossible to regard them as such in the previous canons and protocols of what constitutes a form in visual terms or audible terms. So the question of what's the event at play here?
Mhm.
It's the boundary of form and formlessness that the artistic expression or gesture plays with. But then I also want to sort of maybe the caveat of an artistic event is never a global event per se. Not that
Sure,
events for substance say global, but the actual criteria of an artistic event is much different than say a political event, an amorous event, scientific event.
Sure.
They all have their own sort of distinctions.
Yeah, and I think that he does, I believe he specifies in the little scholium in Logics of Worlds that he is talking about a very specific historical situation. It's Germany, maybe / Austria, post-Wagnerian musical world. And so that is part of the reason why I found it odd that he does include Duteu and Boulez, who are not really part of that world. And Messiaen wouldn't necessarily be either, even though I suppose Boulez was kind of, became part of the, it's hard to argue that he wasn't part of the body of, the of serialism, as Badiou might put it. And also, and
as a really quick
Yeah.
thing too, he also
Yeah.
makes reference to Logic Swords again with the banning of the horses.
Mhm.
But also
Oh.
he mentions the flutes that were carved from animal bones have been found in caves, kind of thing. That's not
Oh. Yeah.
So yeah, he talks about again the idea that yes, there's historically situated events, Wagner creating art, indexing from the can't remember. Anyways, Wagner's work is indexed to previous art, and it's also
Sure.
a reconceptualization of the forms.
Yeah, I mean, I think that there's he mentions that these externalities in terms of Blackbird, so religion and nature and so on. But to me, there's a sense also that, especially because of what happens at the end of the piece, that the 12-tone method itself is almost threatening to be a kind of covering procedure in a way. So let me just show you what I'm talking about. I'm going to share my screen, and I've got, this is the PDF that I threw together. Can you all see that? There should be some text in French there. Everybody, oh yeah. So what I couldn't help myself, and I included some of Messiaen's writings. He created this enormous multi-volume work, and this is the one where he goes through and he discusses and transcribes different bird song. And so I think it's just really fascinating what he says about it. I don't think it'd be, for the purposes maybe for what we're doing right now, not the most interesting thing, but for me, this is it would be really interesting to look at all of this. These are transcriptions, and he makes descriptions of the bird song that seem a little bit weird to, I think, someone now. He talks about the bird song being in essentially a form of C major or A or something, which is kind of to me an unusual thing to talk about bird song in those terms. But going down to the score, so this is what I was talking about. If you're familiar with how the 12-tone method works, you have a 12-tone row, which is a sequence of the 12 pitch classes, right? And a pitch class being an equivalence class for pitches that assumes octave equivalence and inharmonic equivalence. So basically all C sharps and D flats, no matter what octave or register they're in, all belong to the same class of notes. And for better or for worse, in music theory, we use numbers to represent them, and 0 being C, and then up through, when you get to 10, I like to write T. I have a kitten here who's getting in the way. I like to write T and E for 10 and 11. That's pretty standard. In any case, the P stands for prime form of the row, which is essentially the first form of the row that appears. This is and it's combined with its retrograde inversion. So essentially, the row is transposed and then inverted, so that the intervals are, you can imagine them being subtracted from 12, so that they, like 5 and 7 are as interval classes. I don't want to get into the weeds, but this is a very standard way of presenting a 12-tone rows are to combine, say, like a prime form and a retrograde inversion like this. And I've labeled all the pitch classes and then all the forms of the row that appear, they ascend chromatically essentially, and then they switch places so that the retrograde inversions are in the right hand of the piano. And this is pretty remarkable for Messiaen, because when he did engage with the 12-tone method, he was much more likely to, and he was, very famous for essentially setting off the whole tradition of total serialism or integral serialism, where every element of music is serialized, because, and this really heavily influenced Boulez, but Messiaen composed a study essentially, which was called them modes of intensities or modes of rhythmic values, which set off the whole idea of serializing everything. But when Messiaen would actually engage with the method, he tended to do things like scramble the rows, scramble things so that it doesn't actually, the sequence, which is the essential idea of serial music, is kind of messed up. And here it's a very straightforward presentation of prime and retrograde inversion forms. And not only that, it's also mechanical in its rhythmic structure. I didn't put it on the score here, but if you look at the rhythmic values in terms of 16th notes, and I'm just kind of assuming that everyone reads music, and if you don't, that's okay. But this is a 1/16th note. The 8th note is 2. This is 3/16th notes. 2 8th notes is 4 16th notes. And he goes through literally every permutation of 1, 2, 3, and 4. So it is extremely mechanical, and it is a thing that I think that would adds another layer to what Badiou says about this music. Because if he does engage to this extent with the 12-tone method, that raises just a lot of questions. Like I said, I would be tempted to look for ways that this is subverted. I mean, obviously,
Jim,
yeah.
One point I had when listening to it,
Mm-hmm.
and having not heard the piece before, reading it as I went, it seems as though the serial component of the piece
Mm-hmm.
is disrupted by the bird song, right? So the bird song is in a key or in a mode. The rest of the piece is serial or in its attempt, but therefore, because the bird song is structured, it is not completely atonal as a consequence of the piece, right? It's
well, I mean, it's actually, I mean, Badiou says that the opening is not organized tonally or serially, and I mean, I think he's right that this 12-tone material, serial material, comes at the end, and everything before that is, it alternates between the solo, almost improvisatory, virtuosic bits, which are like birdsong, not organized in really any way that we would recognize necessarily. And then that alternates with what we think of maybe as the scene setting, where you have the piano is playing those slow moving like tritones, and that material is sort of setting the scene. And then it
felt to me really similar to Mussorgsky, like proto dissonant, right? Like Songs and Dances of Death or something like that. You know?
Yeah, I can see that. Sure, certainly. Yeah.
The very ending. Yeah.
Yeah. Great gated key.
The piano seems very menacing about accompanying the quote unquote bird.
I mean, yeah, it is, and that's why I think this throws a little bit of a wrench into things. And he doesn't discuss this aspect of it. I say that I mean, what his observations I wouldn't argue with at all. But this just raises more questions for me. The situation that you have here at the end, and because I'm tempted to think of it in terms of, like from the theory of the subject, when he talks about in his sort of reworking of the Hegelian dialectic, you have something, and then that thing placed in the place, and then what the determination happens after that point. If this is the birdsong placed in this artistic context, what happens at the end is kind of like it's mechanical, it's kind of menacing, it very repetitive, the idea of like taking something and permuting it in every possible way is very sort of like Samuel Beckett kind of situation, kind of like the horror of like considering every possibility of something. And so that, I mean, I think that pretty much ends what I had to say about it. And like I said at the beginning, I think I think I raised more questions than anything else. I mean, I would like to write about this, Badu's analysis and all of this. And so anyone who feels like they could answer any of my questions or point me in any directions, that would be great. Because I have done a lot of work on Du Teyu in the context of what Badu has to say about it. And that's my plan with this too. So I'll leave it there and let, I guess we'll be right at 7. I don't know if we want to end or if we want to kind of discuss it more. We could pass it back. I guess I'll pass it back to John at this point. And I'll stop sharing my screen. I hope that was enlightening, at least a little bit, or interesting. So.
That was awesome. Thank you so much. And yeah, I'm happy to stay as long as people have things to say about it. I certainly can't answer any of your questions, but just to tie this back to the ultra filter, we might want to refer to the bottom of 298 and the top of 299 as well. And I don't think this goes beyond what you've already said at all, but it perhaps does sort of tie the two parts of the discussion today together. So the artistic example begins at the very, but it's not an example. The artistic application begins at the very bottom of 298. And to recall, this number 7 here is why principal ultrafilters are of little use if we want to clarify and strengthen the role of infinity in thought. And it's also where we're told that principal filters produce all of the forms of domination, which is a wonderful thing to say. It could also be said that where the arts are concerned, academicism enacts the same type of submission to the one, regardless of the historical period. Everything will be accepted, everything will be a source of delight, everything will be extolled, with the proviso that there's everything must preserve the roots of the art in question that are deemed essential, the implicit system that makes it acceptable. In certain periods, the X that serves as the one for the filter of taste might be figuration in painting, tonality in music, realism in prose fiction, or versification in poetry. But it could obviously change and even adopt opposite views. For example, that the only rule is the absence of rules, that the only thing that matters is that the artist express themselves, that the fragment, the subjective confession, overt sexuality, and arbitrary line breaks prevail over the totalizing construction, the collective fresco, courtly love, or rhymed Alexandrines. In every case, oppression by finitude involves an implicit figure of the one, a system of received ideas, a generally held assumption, producing the filter of taste. Just while we're there for 1 second, I want to put a bookmark on something I want to remember to talk about last time, which is how the ultrafilter can function simultaneously against a foundationalism, whether of taste or something else, and an anti-foundationalism. We know that's always Badiou's position, right? Neither onto theology nor relativism. But I want us to show how that can be done with the ultrafilter. But first, I want to ask you, Jim, does that add anything? Does this text add anything to the discussion? Does it illuminate anything?
Well, I mean, it does make me think of the idea of the 12-tone method itself as, and this was 1952, and it would make sense at this time for, and this is something that, I mean, Adorno talks about this in Philosophy of New Music, that after the break with tonality, that it took a while for the Schoenberg to come up with the 12-tone method, and then at a certain point, it itself becomes this oppressive thing, and it becomes this expectation of, and I think that there's an element of that, of at this point in time, particularly of it becoming something that is oppressive in a way, and which is, and I think from Messiaen's perspective, from someone somewhat outside of that, you know, in the Viennese hothouse or whatever you want to describe it, where all this was happening, it was much easier, I think, to see things where it wasn't such a you know, Boulez is the opposite. So Boulez famously, you know, wrote an essay called "Schoenberg is Dead," you know, saying Schoenberg just didn't go far enough. You know, we have to keep going, which is, you know, that's our, I guess, isn't that Badiou's ethical thing to don't give up, keep going, you know, keep, have faith in the, you know, the idea, which is great. And but you know, things come to an end, and I think that at this point, it might be worth considering whether the sort of totalizing nature of it is something that Messiaen's playing with here at the end, by presenting it in such a I keep using the word mechanical, but that's what it seems like to me. It's almost like like he's wound up this toy and let it go at the end, you know. Even though, I mean, I wouldn't say it writes itself, but there is that element of it, and so I mean that makes it a little bit of a darker. The piece ends in a somewhat of a darker way than I think that Badiou makes out. I mean, just to keep going, sorry. I mean, Boulez solved this problem not just by taking Messiaen's idea of sort of total serialism, of serializing every element of music, so serializing a rhythmic value, serializing articulation, serializing dynamics, and pushing that to the most extreme point, and then moving beyond that extreme point by actually ending up doing what Messiaen had done originally, which is scramble his rows to the point where it took people years and years to unscramble them and figure out what he was doing. Like in Boulez's Le Marteau, the hammer without a master, famously took years and years, and I'm not sure that it was. I mean, this is just me personally speaking, that it was an effort worth doing, because I think that we could just assume that Boulez had something in mind and wasn't just making things up. And you know, it's also, I mean, it's also interesting that an interesting historical overlap in 1952. This is the year, I believe it is the exact year that John Cage, more or less gave up with trying to express himself and this is the moment that Cage, you know, who was in contact with Boulez and Stockhausen and so on, that Cage decided to, you know, embrace aleatoric or chance methods and release himself from the obligation to, you know, to be the author, or you know, to play radios on stage, and whatever happens to be on the radio is the piece and so on. I think it's just an interesting moment in time, the early 1950s, for lots of reasons, political reasons too, of course. Yeah.
So
anyway, I'm gonna try to stop myself from just droning on, which I do in classes.
there's a really quick, interesting observation when we talked about Schoenberg becoming sort of stale and repetitive, and but this is exactly what I think Badiou talks about, and I'm looking for the passage. But eventually, a truth becomes established fact, knowledge, and becomes an opinion. But what it effectively does is it covers over new things, and it continually forms this sort of thing that everybody knows about. It's definable, but it, in a sense, covers over in the sense that he points about as infinite in terms of the way Spinoza thinks of the infinite, which is that it's something is infinite just in case or finite in case something infinite comes along and limits it. So it becomes its own kind of limit to new truths, new events, kind of thing.
I think a related metaphor for it becoming in that way is something I've been learning about, which is this idea of inside baseball. I didn't know much about baseball before moving here, but the fact that there's these, like, the rules are so finite that there's all these ways that people try and cheat within the system, or they think about the strategy, which is so, like, esoteric, and in my mind, I can't really understand it, but it's like you have to understand the finer points of what's going on within the rules in order to proceed, as opposed to sort of breaking new ground, right? And that's sort of a similar, I think, example of what's going on.
Yeah, I think the World Series is happening as we speak, or it's about to start pretty soon. Speaking of baseball, I saw that that Daniel posted this this article. If I'm not mistaken, this is the guy that Badiou. I think in a footnote in Logics of Worlds, he says that on matters of music, I will basically like just concede to Francois Nicolas, if I'm pronouncing his name correctly, and he does have some very interesting things to say about like what the transcendental in terms of Logics of Worlds would be in musical terms.
There is another person I know, Kevin Lafave, who did his PhD on Badiou in music. He's a professor of music in Arizona.
Oh.
I can get you connected to him. I think you would have much to discuss, Jim.
Sure, because the other person I know that's really engaged as much with Badiou and music is J.P.E. Harper Scott, who actually, his last book was called The Event of Music History, and he wrote a book, I think it's called The Quilting Points of Musical Modernism, that's very heavily uses Badiou, but he recently just dropped out of academia, I believe. I'm not sure exactly why. But it's not something that in the world of musicology, especially in my field of music theory, there is literally hardly anyone engaging with this sort of material. So, which I think is kind of a shame.
Yeah. All right. Well, I think this might be a good place for us to close for now. This is great, Jim. Thank you also, of course, as always, to our fearless convener and leader, John Bova, for a great session. Why don't we do this? We'll send a note about our plan and our structure. I guess we've lost track, John, with specific pages we want people to read. Sure. One suggestion that could be useful is, in fact, to try and do that so that people can read the same material before we meet, not next week, but the week after, so that we have something that we've thought about in advance that will increase our conversation and our dialogue. That's just one recommendation. And I know
ironically, this is the one moment where we know what the imperative is, right? Finish the book, because next
right.
one is our last meeting.
Fair enough.
Can I ask a question? 2 weeks from now, I think is Thanksgiving, right?
Well, let's see.
Is that right?
No, it's not exactly. That's 17th.
The 17th. That's the week.
It's not Thanksgiving. It's not.
Okay.
The week before. So we did set it up. I mean, this group can meet as much as it wants. There's no limitations per se. So it doesn't have to be our last meeting. I don't want to torture people, but I know that the folks in Australia, the Badiousian community in Australia, took over a year to read this book. I think when we planned this, we were quite ambitious, thinking we could finish it in a couple months. So let's think about that, John, and get back to the group with our suggestion on what to read. Or we could take the cavalier approach and say, just finish the book. Maybe we could get a show of hands. Do people feel like they're in a place that they can finish the book? Not including the various appendices, but actually finishing the core.
I'm pretty much in the home stretch myself. So yeah, it's totally feasible. But my suggestion would be to chapter 22, make that a focal point. for the next one, because that basically just gives the hard doctrinal summary of what the book was trying to accomplish. Lots of robust definitions of what he's playing with. And then, of course, the latter part of the book is just how the four truth procedures themselves work in conjunction with the book. My thoughts.
I like that.
Yeah, the index of the work, we have to make it to explicitly talk about that, even if we say, well, some of the rest is examples. Quite right.
Why don't we do this? John, why don't you think about that, taking Chris's suggestion, and let's just expect an email in the next couple of days with instructions. I think 22 is definitely a must, but we can do other things as well. And, you know, the next time we meet doesn't have to be our last meeting. We could do whatever we want. We could have a day where people get presentations about the text. We could have a day where we just do unresolved questions. We could do whatever we want. So, and also use the Zulip or Twitter or whatever means you wish to communicate what your preference is in terms of finishing this book. That's what I would say.
Sounds good.
Thanks again, John, and everyone.
Thank you. And
We'll see you soon.
Thanks so much, Jim.
Yeah, Jim, it was great. Thanks, everyone.